Hi everyone, we are continuing with probability and we're talking lesson 2. Today's a really important lesson. We are going to talk about union and intersection using a Venn diagram, and we're going to talk about how we're going to add probabilities. So in the do now, you're given 8 cards numbered 1 through 8, and they're asking you to complete the Venn diagram for all the possible outcomes for drawing one card. So probably haven't seen a Venn diagram kind of in a long time. So when you're starting and putting all your numbers in your Venn diagram, you're always going to work from the inside out. So are there any numbers that are even and prime? And there's only one even and prime number, and that's 2. So that's going to go in the overlapping of evens and primes. There's no other even prime numbers, okay? All the other evens, 4, 6, 8, are not prime. So some of the prime numbers, what are prime and definitely not even: 3, 5, 7. Evens, we know 2 is already in there, but we could also use 4, 6, and 8, which leaves us with only one other one missing, and that's the number 1. Is 1 prime or even? No. So where does that belong? Just anywhere outside of the Venn diagrams. Okay, so let's answer some questions. What outcomes are even? So some of the even outcomes are 2, 4, 6, and 8. Okay, so what is the probability of drawing one card and it being even? 4 out of 8. Okay, there's 4 possibilities: 2, 4, 6, or 8. What outcomes are prime? Well, the primes are 2, 3, 5, and 7. So what's your probability of getting a prime number? That would be 4 out of 8. Okay, so now let's talk about this. What outcomes are even or prime? Okay, so this means or. This is, put a little note here, or, okay, even or prime. So what numbers are even or prime? Well, there's 7 options: 2, 3, 4, 5, 6, 7, and 8. The only one that's not even or prime is that number 1. So even or prime would be 7 out of the 8. What outcomes are even and prime? Okay, so really big difference. Or versus and. And notice how your little symbol switched. It almost looks like it originally looked like a U or a horseshoe. That represents or. When it's the other way, this represents and. To me, it almost could be an A without your little line, making the A. So that's a good way to remember it. So what options are even and prime? That's only one option, the 2. So 1 out of 8. And notice they are complements of each other, right? Even or prime and not even or prime has to be your 1/8, okay? They're complements. So let's look at your Venn diagrams, union versus intersection. So your union is your or, and it means everything. One or the other, A or B, you would include everything in both circles. Where intersect, okay, you could see where we highlighted in green, is what both A and B have. So this next definition is really important: mutually exclusive events. 2 events, A and B, are mutually exclusive if they have no outcomes in common and they can never occur together. So for mutually exclusive events, A and B, your probability would be 0. They are never going to occur together, okay? No outcomes in common. Okay, so if you look here and you look at the Venn diagrams, notice A and B do not overlap. Okay, so they are mutually exclusive. So let's just go back to the card questions. It says for the cards numbers 1 through 8, are the events is even and is odd, are they mutually exclusive? Explain. Yes, they are mutually exclusive because the probability of A and B, right, is equal to 0. It can't be even and odd. Remember, it could be even and prime, but it couldn't be even and odd. So now for part B, it says numbers 1 through 8, the events are is prime and is even. Are they mutually exclusive? Well, I just kind of answered that. No, because 2 is both even. I'm going to say prime is both prime and even. Okay, so understand even and odd are mutually exclusive, but prime and even are not mutually exclusive. Okay, so this next little rule is going to be really important. In the next rule, we're going to be finding probabilities. So when you're finding the or probabilities or unions, you are going to have this little overlap, okay? So here is your rule. The general addition rule is to find any two events that are A and B, okay? To find this, the probability of A or B. It's going to be the probability of A plus the probability of B minus the probability of A and B. So remember, when events are mutually exclusive, the probability of A and B are 0. Okay, so the probability, let's just talk about this example. We're talking about Gary and Jane. So Gary and Jane have a child with blue eyes, and the probability of that is 25%. And the probability that they have a child with blonde hair is 0.5%. So blonde hair is a half, 0.5. The probability that they have a child with both blue eyes and blonde hair. Blue eyes and blonde hair. So this word is important. That is 0.125. Okay, so understand that and is represented by this probability of A and B. Okay, that's 0.125. So find the probability that they have a child with blonde hair or blue eyes. Blonde hair or blue eyes. Okay, so we could do that using our little formula. Remember that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so watch how I'm going to write my symbol. The probability of A or B, okay, is equal to, what's the probability of A? Well, probability of A I'm going to call blue eyes, so that's 0.25. The probability of B is blonde hair, which is 0.5. And then we're going to subtract out the probability of blonde hair and blue eyes, which was 0.125. Okay, so that's going to give us our probability of blue eyes or blonde hair. So you can go into your calculator. I'm going to just bring it off to the side, and I'm going to do 0.25 plus 0.5 minus 0.125. And there's my number, 0.625. So I'm going to write that, 0.625. Are the events blonde hair and blue eyes mutually exclusive? In other words, could somebody have blonde hair and blue eyes? Yes. So they're not mutually exclusive. No, because you could have both outcomes occur. Okay, a person can have, I would say, a person can have both blonde hair and blue eyes. Okay, in other words, the probability of A and B isn't 0. There's a probability that someone comes out with blue eyes and blonde hair. It was 0.125. Okay, so in the next one, it says find the probability that a child has blonde hair but not blue eyes. So this is interesting. Now, they're telling you to make a Venn diagram. So I'm going to just sketch a little Venn diagram for you. Okay, let's talk about these two. Okay, if I have this and this, right? And I know I'm going to make this blue eyes and this one blonde hair. Okay, remember you always have to work from the inside out, and we know the intersection of blue eyes and blonde hair. Weird, doesn't blonde have an E at the end? Whatever. So when you guys look at the intersection, we know blue eyes and blonde hair was 0.125. So I'm making this 0.125. Now you knew blue eyes, just blue eyes by itself, blue eyes was 0.25. So now I have to take those blue eyes and subtract out that 0.125. So blue eyes should have a 0.125. Right? Blue eyes should have a 0.125. And then there's blonde hair. If you just had blonde hair, you had 0.5. So now take that 0.5 and subtract out 0.125. So I'm going to go to my calculator and just show that 0.5 minus 0.125 is 0.375. So blonde is 0.375. Okay. Now, they want the probability of, it says, find the probability that a child has blonde hair but not blue eyes. So blonde hair but not blue eyes. Blonde hair was 0.5. Yeah, this looks good. So we want blonde hair, probability of blonde and not blue eyes. Well, who would that be? Blonde hair, not blue, is this. 0.375. Everybody agree? Blue. Oh, did I just mess that up?